All right, so we are now looking at, yep, we're working, all good. We are now looking at our second exercise for this probability unit. We are looking at unions and intersections. Now, you guys would have heard a little bit about intersections when you were working on quadratic unions. Unions when you're looking at quadratic inequalities in Maths B Advanced. We're going to be using a bit of that set notation as well today. The other thing we're looking at today is intersections. Now, to look at unions and intersections, we're going to use a couple of key diagrams, the Venn diagram and a two-way table. That really helps us get an understanding of what unions and intersections are. So to start off, here is your activate prior knowledge. We've got some words here: null set, Venn diagram, set, and sample space. You've got to match the word with the definition. I reckon sample space you should know from our last video. Venn diagram, I think some of you guys will know that one. You might just have to use a bit of process of elimination there to figure out set and null set. Anyway, pause the video, write down these definitions with the matched up diagram, with the matched up definition, very important. Next, what we're going to look at is a heap of words here that come up. We've got unions and intersections and a few other things. And the easiest way to explain this, I think, is by looking at some examples. So here's a few sets. We've got set A, that's got numbers 1 to 5. Set B, we've got those curly brackets that we're familiar with that mean the start of a set. We've got odd numbers there between 1 and 10. And set C, we've got even numbers between 1 and 10. So let's have a look at some of these words. So the first one I want to talk about is the intersection. So intersection is like an upside down U, kind of like a little N. And these are all the elements that are in both sets. So it's got to be in both. So for example, in the above sets A and set B, A intersect B is the numbers that are in both A and B. So you can see we got 1 in both. We've got 1 in both. And we've got 3 in both. And we've got 5 in both. So A intersects B is the set of numbers 1, 3, 5. Maybe as a little challenge here, you could write the intersection of set A and C just to test that you understand this. If you can, then you're doing well. The next one we want to talk about is union. So this is like kind of a wide U shape. And this means all the elements that are present in either set. It's kind of like or. Intersection can be and union is or. So all the elements that are present in either set. So the union of A and B is going to be 1, 2, 3, 4, 5, and then any in set B we haven't already said, which is 7 and 9. So it's both. For a check of understanding, check that you could write the union of sets B and set C. Mutually exclusive. This one you want to make sure you've got written down. A situation where there are no elements that are in common between sets. So in the above sets, B intersects C is an empty set, the null set. Ooh, that's a nice symbol for that word we learnt on the previous slide. The null set. You can write that as the 0 with the slash between it. So if you look at set B and set C, there are no numbers that are present in both sets. So we can say that the intersection is the null set, therefore they are mutually exclusive. Now, something else that can be a little bit confusing, you want to make sure you're across and pay attention to, is your question asking about the n of A or the probability of A? So when you've got an n, it's talking about the number of elements in the set. If you've got a pr or a p, it's about the probability of that. So the n, the number of elements in A intersect B, is 3. Because in A intersect B, we had 1, 3, and 5. So there's 3 elements. Whereas the probability of getting something that is in both A and B, when we get a random number from between 1 and 10, then you've got 3 options out of the 10 total. So n is a number, pr is a probability. Now, Venn diagrams and two-way tables. These are what we're going to use today to understand unions and intersections. Really useful for visualizing probabilities. So really helpful for understanding complex questions. So if you get a big worded question, you don't understand what it's asking, a really good idea is to try, can we fit this information into a Venn diagram? Or can we fit this information into a two-way table? So for a Venn diagram, this number here in the middle is your intersection. So this one is an n, so this is the number of elements that are in both set A and set B. Over here, you've got what is in A that is not in B. Over here, we've got what is in B that is not in A, so there's 4. And then you've got 2 on the outside here. Drawing that outside box is really important. 2 that are in neither A or B. Now you've got your two-way table here. Here is A, not A complement, remember. B, not B complement. So the total in A is going to be 4. You got 1 plus 3. The total in B would be 5. 1 plus 4, 5. Now each of these, and then here's our total number of outcomes, 10. Now, each of these little 4 squares here represents some intersections. So this one here is the number of elements that are in both A and both B, intersect of A, B. This number here is the intersection of B and not A. So that is what is in B that is not in A. So that is going to be that 4, this right-hand side of the Venn diagram, and so on. So you'll get a bit of an understanding of how these ones work. Next, I'm going to open up my whiteboard and we're going to have a look at some examples here. Here we go. So let's look at a similar kind of situation. We're taking numbers, random numbers from between 1 and 10. Set A here is getting our even numbers, 2, 4, 6, 8, and 10. And set B, we've got getting 1, 2, 4, 6, 7, and 10. So if you like here, you can pause the video and try this on your own, and then check back and see if you got the same answers as me. If you're not sure how to get started, then let's work through it together. We want to represent the two events A and B in a Venn diagram, showing the number of elements belonging to each region. So we're not talking about the probability here. We're not talking about Peru. We're talking about the number n. So let's call this one A and this one B. And we've got to show the number of events belonging to each region. So probably the easiest way to start here is to try and find the intersection. What is in both A and B? So 1 is in B but not in A. but we can see we got 2 in both. 4 is in both. 6 is in both. And 10 is in both. So the number of elements that are in both, we've got 2, 4, 6, and 10. So there's 4 different elements there. So we're going to chuck a 4 in here for the intersection. Next, we've got to say, well, how many are in A that are not in B? So let's have a look at our list here. And there is just the 1. That 8. So there's 1 element in A that is not in set B. Let's have a look at B. How many elements are there in B that are not in set A? There is 1 and 7. So that's 2 elements. Now, something that is really important to remember is our total sample space. So our sample space was the numbers from 1 to 10. Now, not every number between 1 and 10 fits into A or B. So if we think about our total sample space, numbers from 1 to 10, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So which of these have we not already used? Well, 1 is done. We put 1 in set B. 2 is already been used. Now 3. 3 is not in A or B. 4, that's in set A and B. 5, that is not in either. 6 has already been used. 7 is in set B. 8 is in set A. 10 is in set A and set B. And then we can see that 9 is in neither set. So there are actually 3 elements, 3, 5, and 9, that are in our sample space that are not in set A or set B. So we need to put a 3 on the outside here. So now we've done the hard work of representing these events on our Venn diagram. These follow-up questions will be can be quite easier. So even if you weren't able to do the Venn diagram on your own, I'd suggest now pausing and trying to find the answers to these questions here on your own. I'm going to go through the answers now. The number, remember, N means number, not probability. So the number of elements that are in A intersect B. So that means A and B. So you can see the intersection for this question here, the intersection of A and B, that's this little center bit here. So the number of elements in there is 4. Now we got the number of A union B. So that means either A or B. So now we're talking about everything that is in either A or B. So we got 1 element here, 4 elements here, 2 elements here. So we got 6 plus 1, 7. Part C. If a number from the first 10 integers is randomly selected, find the probability that the following events occur. So per A. Now we're talking about the probability. So the probability of getting a number from set A, Well, you could get, there's one element here and there's 4 elements here. So our numerator, there are five possible outcomes that lead to that event of getting something from set A. And the total number of numbers in our sample space is 10. So 5 out of 10. We want to simplify our answer here, of course, so we might write 1/2 or a decimal, 0.5. Now we're interested in this next question, the probability of drawing A intersect B. So what's the probability of getting a number that is in both set A and set B? So that is talking about this one here, getting the 4. So there's 4 outcomes for this event that satisfy the conditions of this event. And there is 10 total numbers, so 4 out of 10. And then we want to simplify this, so either 0.4 or 2/5. All right, first example done. Check your answers. Hope you did well. Here is our second example. We got a group of 40 people. 28 like drinking coffee, so we're going to call that C, people who like drinking coffee. 11 like drinking tea. I don't know why 11 like drinking tea. It'd be nice if I could get this. Anyway, we'll work on getting all that working. 11 like drinking tea and 3 like drinking both coffee and tea. We want to illustrate this information on a Venn diagram. So remember, drawing in this box on the outside is really important, so we can include our whole sample space. So we got a nice box here, and then we got a circle and another circle. So let's call this one coffee, and let's call this one tea. Tea for tea. 40 people in total. 28 like drinking coffee and 11 like drinking tea. 3 like drinking both coffee and tea. Now, you can run into problems here because 28 people like drinking coffee. That doesn't mean 28 people who like drinking coffee alone. Some of these people could also like drinking tea. So what we're going to do here is start with the intersection. 3 like drinking both coffee and tea. So the intersection, there are 3 people here who like drinking coffee and tea. So we know there's 40 people in total. And we've just taken away 3 of them. So we've still got 27 people to fit in. All right, sorry, my mistake. Obviously, 40 minus 3 is... I still can't get that. My face to stay there. 40 minus 3 is 37. So if you think about it, 28 plus 11, that is 39 plus 3. It can't be 28 here and 11 here because we've only got 40 people. So what we got to do is account out of the 28 people that like drinking coffee, 3 also like drinking tea. So they've already been counted here. So to figure out what number goes here, the number who just like drinking coffee alone, we are going to do 28 minus 3 and get 25. Because we've got to split this 28 who like drinking coffee into the ones who like both and the ones who just like coffee. With the 11 here that like drinking tea, again, some of these, well, 3 of these people also like drinking coffee. So to figure out how many just like drinking tea, we're going to do 11 minus 3, 8. Now, what is super important here is for us to also consider our total sample size. So there are 40 people in this group. So far we've got 25 plus 3 plus 8. So that would be 5 plus 3 is 8, plus 8 is 16. So far we've got 36 people accounted for here, but there's 40 in total. So that means there must be 4 people who don't like drinking either. Now have a crack at doing these ones as well. I'll go through now how to read this off the Venn diagram. So this is after the number of people who enjoy drinking tea only. So that means we are not interested in the people who like drinking coffee as well. We are just interested in this number of people here. So that is 8. People who enjoy neither coffee nor tea. Well, that is the people outside of the 2 circles, the 4. Part C. Again, give this one a shot if you haven't already. Find the probability that a person chosen randomly from the group will enjoy drinking coffee. So, the number who like drinking coffee, that's our numerator. So, the probability of liking coffee. Our numerator is the total number who like drinking coffee, so that's 28. Remember, this would include people who like drinking coffee and tea. Out of our total sample space, 40. Now we want to get this into its simplest form. I am going to divide by 2, I think, here. Oh no, maybe 4. Yes, let's divide by 4. You could divide by 2 if you want, but let's divide by 4. So divided by 4 is 10. And divided by 4 is 7. So 7/10 is our probability of someone likes drinking coffee. Let's now think about the probability of someone who likes drinking tea. So now we've got to think about the total number who like drinking tea. So that is the 3 who like drinking both and the 8 or the 11 in total who like drinking tea. So the probability that someone likes drinking tea, our numerator is 11 out of the total 40. No common factors here. The probability that someone will like drinking both, so that's like the probability of the intersection, the probability that they like coffee and tea. So that is 3. Our intersection here, the number of possible outcomes is 3 out of the total 40. Nice. We've got one more example now. To have a look at. This one here, we're really focusing on connecting the information between a Venn diagram and a two-way table. Some questions are better suited to each one, and with practice, you guys will understand which ones are better for certain types of questions. So here we got a Venn diagram here showing the elements in set A and set B, and we got an intersection, and then we've got the elements that are in neither. So let's transfer this information in the Venn diagram to a two-way table. So the easiest way to start here, I think, is with the intersection. So the intersection of A and B is 2. So there's 2 elements there in both. Now this part here, this is representing what is in B but not A. So that is, so that was the light blue area. What is in B that is not in A? Now we are talking about this section, right? It doesn't include the people who are in A. So this one is 4. All right, next we got down here. What is in A that is not in B? So that is going to be this section here. R3. And then finally, we've got what is in, how many elements are either in neither A or B, and that is 6. Let's add up our totals. So our total probability, the total number of outcomes that are in B is the 2 and the 4. So you've got 6. Total in A is 2 plus 3, which is 5. Everything that is not in A, well, that is just the 4 and the 6, right? So that's 10. What is not in B? So that's everything that's not B. So that's 3 and the 6. 3 and 6, that's 9. And now what we should happen is we should get the same number if we add these 2 and these 2 to get our total. If you've got something that's not the same, you know you've probably made a mistake somewhere. So 10 plus 5 is 15. 6 plus 9 is 15. Good. We know we're onto something. If you like, have a pause, see if you can try and interpret these information to find the answers to these questions here. I'm going to go through them now. So this is about the number of elements that are in both A and B, the intersection of A and B. So you can read that one off. That is 2. Now we've got the number of elements that are not in A, the complement of A, and are in B. So it's up to you which one you find easier to read the information from here. I kind of like the two-way type table for this one. So what is not in A but is in B? That is 4. What is in neither A nor B? The intersection of not A and not B. That's this. What's in not A and not in B? 6. 6. How many elements in total are in A? You've got the 3 plus the 2, the 3 plus the 2, 5. The number in total that are not B, 9. Or thinking about what's not in this circle, 3 plus 6, 9. The number of elements that are in A union B. So pay attention. Now we've got a union, not an intersection. For union, I like the Venn diagram because you don't end up double counting. So what is in either A or B? We've got 3 plus 2 is 5 plus 4 is 9. You can do the same through this table here by counting up the 2 and the 3 and the 4. Or you can think about, well, that is the complement of the A intersect, not A intersect, not B. So to find our probability now of A intersect B, so the probability that we're getting a number that is in both A and B, the total number of outcomes there is 2. and our total is 15, 2 out of 15. The probability of getting A and not B, the intersection of A and not B. What's the probability of getting something that's in A and not in B? A, not B, that is 3 out of 15, which of course we want to simplify. Common factor of 3 here, divide by 3, 1/5. All right, that's it. You will now work on the questions in class.